Ladies and gentlemen, welcome back to another video. Here we've got our test 2 review, and let's start making it happen. This test 2 practice should be posted, so you should be able to see it, and then your test starts on, what, the second or the third, perhaps. So I wish you all well on the exam. Email me if you have any questions. Here, and hopefully I won't be in the hospital this time, so I can be able to answer them. Here, the derivative of a function gives the slope of the tangent line to the graph of the function at a point. What is this? Okay, this is going to be true, right? This is what the derivative is. The derivative is going to tell you, f prime of 3 is going to tell you what is the slope of the tangent line of, f at 3. I'll compute the derivative of e to the x, x to the e. Okay, so here we're just going to do our product rule. We're going to say derivative of this guy times this guy. So what's the derivative of e to the x? Right, it's going to be e to the x. And what's the and so we've got xe. So we need to have one term is going to be e to the x, x to the e. So e to the x, x to the e, and e to the x, x to the e. We know that these are both possibilities because it needs to be addition when we're doing this product rule. So we can already go ahead and get rid of the first one, the third one. Now, our second term is going to be derivative of this guy times this guy. Well, what is the derivative of x to some power? What's the derivative of x cubed? It's going to be 3x squared. So here, the derivative of x to the e is going to be ex to the e minus 1. And so here we end up getting is ex. Where is ex to the... Oh, is this really not here? Yeah, okay, so... Oh, okay, here it is, e to the x plus 1. So here what we would end up getting, right, so let's go ahead and e to the x, x to the e. I tried to do it without writing, but it's a little too complicated. This guy, derivative, right, is going to be what? Well, we've got e to the x, this derivative of this times this, like this, plus the derivative of this is what? E to the e times x to the e minus 1, right, times e to the x, right, because we've got derivative of this guy times this guy. So now we combine our powers. We've got e and e to the x, and this guy is going to be here. E, we've got 1 power of e and x powers of e, so that'll be e to the x plus 1, x e to minus 1, right? And so this here would be our answer. So it would be this guy here. Okay. Compute the first derivative of 1 plus sine 2x to the 10th plus pi. We can go ahead and do this, guys. No worries. We're going to have 1 plus sine of 2x to the 10th. Got 1 plus sine of 2x to the 10th. 1 plus sine of 2x to the 10th. Okay, so we just do our chain rule, right? So first, we've got our we've got this outside layer. What is this outside layer going to be? It's going to be, so we'll just circle this in red. This will be 10 times 1 plus sine 2x to the 9th times the derivative, we'll call this guy g of x, times g prime of x, right? So what is the derivative of 1 plus sine 2x? Well, the derivative of 1 is 0. The derivative of sine 2x is going to be, we have to do another chain rule. So this is going to be equals 10 times 1 plus sine 2x, right, to the 9th. And then the derivative of g, like g prime here, well, we've got to take sine derivative, so it's going to be cosine of 2x, right? And then we're going to have, after cosine of 2x, right, what's the derivative of this inside 2x? This is just going to be 2. So here our answer would be 20 times cosine 2x times 1 plus sine 2x to the 9th, right? This guy here would be our answer. I'm not going to write that just because, whatever, but that's what it is. Okay, same thing here. We're going to have compute the derivative of this guy at x equals pi. Okay, we got f equals tangent x over x. Tangent x over x. So f equals tan x over x. Okay, f prime is going to be what? We do low d high, that's the derivative of tangent. It's going to be secant squared. Minus high d low, what's the derivative of x? It's just going to be 1 divided by low squared, which is going to be x squared. So now this guy here is going to be secant squared x over x minus tangent x over x squared. Okay, so now f prime of pi, which is really the question that we asked. And make sure that when you're looking at these questions, you always, you read the whole question. It's got to make sure that it's at x equals pi. If you do this whole thing properly and then not plug it in, you're going to get points taken off, right? So you definitely want to make sure that you're reading the whole question. Make sure you check your work. F prime of pi, well, what is secant of pi? Well, I don't really have secant memorized in the unit circle, but what we can say is 1 over cosine of pi. And what is cosine of pi? We know it's -1, right? So this means that secant is -1. Secant of pi equals this guy, which is -1. So secant squared of pi is 1. So it's going to be 1 over pi minus, what is tangent of pi? Well, tangent of pi is going to be sine of pi over cosine of pi, which is just 0, right? Because sine of pi is 0. Cool. So now we've got 1 over pi. Would be our answer. Okie dokie. So this guy's 1 over pi. Determine the slope of the tangent line at x equals 0 for all of these guys. So we've got pictures. We don't even need to do none of this, right? So what is the slope at 0? This guy's going to be negative, of course. What is the slope here? This is going to be undefined, and it's infinite. Super high here. Infinite just means that it actually points up, right? So here our slope is going to be 0 because we're at a flat point. Here our slope is positive. You can see it's going up a little bit. And then here, this is where we're at a cusp. And what the cusp means, if you remember from last week's video, it just means that you have infinitely many tangent lines underneath it, right? So that's why it's undefined. It's not undefined because the number is undefined. Like here, it's like it's upwards, it's just infinity, right? And there is only really one tangent line here, but it's just a vertical line, of course, so it's not a function. Whereas here, we've got infinitely many tangent lines that support it from below. Okay, let's get into our second page. You can expect the format to be pretty similar to the last test, right? They're gonna be fairly similar in terms of how many questions, stuff like that, how it's graded. But yeah. Okay, compute the derivative of y equals x to the x. Ooh, this one's tricky. Whenever you see x in the exponent, what do you have to do, right? This means that we're gonna have to do logarithms. So y equals x to the x. This means that ln of y is going to be x ln of x, right? So you put the ln in front, you bring the x in front. Okay. So now let's start taking our derivatives. Derivative of the left-hand side is going to be y. What's the derivative of ln? Right, it's going to be 1 over y, right? And so we're going to have 1 over y, yeah, times the derivative of the inside, which the inside here is y, so we're going to have y prime. This guy is going to equal what? Well, we have to do our product rule on this. So we have to get this guy times the derivative of this guy. So we're going to have x divided by x plus this guy times the derivative of this guy. It's going to be ln x. Okay, so now we found that y prime is going to be 1 plus ln x times y. And so now we're done, right? We finished the problem. Here it says give your answer only in terms of x. So now this is going to be a super easy way to lose points on the problem. We don't just plug in y equals x to the x. So here we have y, but y equals x to the x. This is just going to be 1 plus ln x, right, times x to the x. And then now you're done. You have 1 plus ln x to the x. 15-foot ladder is resting against the wall. Okay, so now as we got related rates, we need to make sure that we are we're drawing our picture, right? So 15-foot ladder is resting against the wall. The bottom of the ladder is initially 12 feet from the wall. Okay, we're gonna have like this. The ladder is 15 feet. Okay. This horizontal distance I'm going to call h, and this vertical distance I'm going to call v, right? Okay. The bottom of the ladder is initially 12 feet away from the wall. Suppose you Suppose you begin to push the ladder toward the wall. at a constant rate of 1/4 foot per second. How fast is the top of the ladder moving up the wall 12 seconds after you start pushing? Okay. So here we're going to have to look at after 12 seconds that we want v prime of 12, right? This is what we're gunning for. Top ladder moving up the wall 12 seconds after you start pushing. Okay. Okay, cool. So a 15-foot ladder resting against the wall. The bottom of the ladder is initially 12 feet away, right? And so if H initially, maybe I'll draw like an initial picture. Right, it's going to be like this. This is 15, which means that this is 12, which means that this is what? 7 or something. I actually don't remember. Squared minus 12 squared, 9. Okay. Which means that this is 9. Okay. We've got this guy now. Means that it was we're just doing our Pythagorean theorem, right? We've got this height here. I don't know if this will come in handy, but maybe it will. We'll see. So all right, let's see what we got. Well, we know our Pythagorean theorem. We're going to say v squared plus h squared equals 15 squared, right? This is our formula. So now we take derivatives. Well, we can just take our time derivative everywhere. So we're going to have 2v v prime plus 2h h prime equals 15 squared, right? Now we start plugging stuff in. We know that, what is it? A 15-foot ladder is resting against the wall. The bottom is 12 feet away. Okay, so we know that v prime, no, sorry, h prime is a quarter, right? So h prime is always a quarter. And so it looks like we just need to solve for v and h. Okay. So after 12 seconds, right? So let's go down here a little bit. So need v and h. V of 12 and h of 12. Right. And let me go ahead and erase this. This actually should not be helpful. Okay, so we've got need v of 12 and h of 12. How do we get this? Well, the way that we get this is we're going to look here and we're going to say that we're moving a quarter foot per second, right? And we want to figure out what it is after 12 seconds. Okay, so after 12 seconds, we've got this picture here. The ladder is still 15 feet, of course. But we've moved, you know, here h was initially what it was, where is it? Initially 12 feet away from the wall, but after 12 seconds, right, this guy here is going to be 12, is what it was starting at, minus 12 seconds moving at a quarter, right? So we've been moving a quarter closer the whole time, and that's been for 12 seconds, which means that we've gotten 3 more feet closer. So instead of it being 12, it's going to be 9. So now this guy equals 9, which means that this height is 12. So we know that h of 12 is going to be 9, and v of 12 is going to be 12. So h of 12 is 9, v of 12 is 12. This means we plug them back in here. We have 2 times 12 times v prime, which is what we're solving for, right? Yeah. Plus 2 times 9 times a quarter, right? Is going to equal 15 squared. So now you just solve. So v prime equals 15 squared minus 2 times 9 divided by 4 is going to be 18 divided by 4. Leave it like that. We don't need to simplify. And then we're going to divide this whole thing by 24. And you can always just leave it like this. You don't need to simplify nothing on an exam. Just leave it like this. So v prime, should look like a prime, is going to be this. This is going to be your final answer. How quickly it's moving up the wall here. Now, okay, it says to round. I will not ask you to round on the exam. This is the practice exam given from the other professors or whatever. But I won't ask you to round. Okay, final question. Find the equation of the tangent line of this guy here at x equals 4. Let's make it happen. So f equals ln x root x. This should be not too bad. I think that we can do it. F equals ln x root x, right? So f prime is going to, right? We see that we need a tangent line. We need to be solving for the derivative, right? F equals ln x to root x. So we're going to go ahead and take our derivative, right? So derivative of ln x is going to be 1 over x times root x plus ln x. What's the derivative of root x? Well, it's x to the 1/2, right? This is ln x to the times x to the 1/2. So this is going to be 1/2 x to the negative 1/2. So 1/2 x to the negative 1/2. Okay, so actually we look at it. We've got an x in the bottom, and we've got half a power of x in the top, which means that we can actually simplify this to 1 over x to the 1/2 plus 1/2 ln x times 1 over x to the 1/2, which I don't know if this will really help us, but it's just kind of fun to look at. So this is going to be 1 plus 1/2 ln x times we'll say x to the negative 1/2. Okay, so this is what we have. Now what we're asking for is that x equals 4. We need to find the equation of the tangent line. So the slope, right, so f prime of 4 is just going to be what? 1 plus 1 over 2 ln 4 times x to the negative 1/2. So take the square root and divide by it. So we're going to multiply by 1/2, right? Because we've got 1 over root 4, which is 1/2, of course. Oh, whoops, I was writing kind of. I should 1 over. Okay. So we've got that going, taken care of. Now what we can do is look over here at, we just need to find, our intercept, right? So now we've got y equals, I'm just going to call this quantity star, just so I don't have to write it out, but this is what our slope is. Star x plus b. And where's it intercept? Well, it's got to intercept this guy, at x equals 4. So it has to intercept at 4 comma ln of 4 times root 4, which is 2, right? So 2 ln 4, so root 4 ln 4, it's going to be our y value and x value is 4. So it has to hit this point, 2 ln 4. This means that 2 ln 4 equals star times 4 plus b, which, means that b equals 2 ln 4 divided by 4 star. Okay. And now we can cancel maybe. We can say ln 4 over 2 star if you want to. It doesn't matter. You can simplify the 2 and 4 if you want to. You don't have to. Okay, so now we've got ln 4 over 2 star. And so then this means that the equation of our tangent line is y equals star of x plus ln 4 over 2 star. This here is going to be a tangent line to ln x root x at x equals 4. Go ahead and actually write this when you're doing that. I didn't want to, make it too confusing, so I wrote the star, just so I didn't have to write. Wherever you see star here, you should be thinking 1/2 times 1 plus 1/2 ln 4. I just didn't want to write all that. Now, you should be writing this on exam. If you write like star or smiley face or something like this, and you don't actually end up plugging it back in at the end, it's going to be points off, right? Okay, so I think that covers everything. Yeah, okay, so that's going to be the whole practice exam. I hope that you all have a wonderful day. I hope that you have a good time studying. Email me if you have any questions, and I will see you in the next one. Peace.